You're eating healthy, so why do you still feel like there's something missing? You might think that it means that you're not getting enough of the right kind of foods. But what if the real issue was something hidden inside the very foods that you're already eating? Compounds called anti-nutrients. There's this growing idea floating around that maybe plants don't actually want to be eaten. And because of that, there's been this massive push in the health space toward cutting out plant foods entirely. But is that actually necessary, or is this just another nutrition trend that's taken one piece of truth and blown it way out of proportion? I wanted to find out, so I started looking into it. And what I discovered is, yeah, anti-nutrients do have side effects, unpleasant ones at that. But there's a much bigger picture here, and one that's almost always left out of this conversation. So with this video, I wanted to break down what anti-nutrients actually do in the body, what the research has to say about cultures that eat a ton of them, and most importantly, how we can work with them instead of against them. So, what exactly are these anti-nutrients? Anti-nutrients are natural compounds found in all sorts of plant foods that can interfere with our digestion, our hormones, and mineral absorption, among other things. They exist because plants can't run away. So instead, this is how they make themselves less appealing and discourage overconsumption. These compounds include things like phytates, lectins, oxalates, goitrogens, tannins, saponins, trypsin inhibitors, and few others. And if you Google them, you'll probably see them described as toxic. And technically, that's not really wrong, but context is everything. The way these compounds affect the body depends on three major factors: how much you're actually eating, your individual health status, and how this food is prepared. And this is where this discussion gets really interesting, because in most cases, traditional food prep methods neutralize these compounds almost entirely. And this is something we see reflected in real-world data as well. Take, for example, the Mediterranean diet, the blue zones, and other plant habit diets, all of which are linked to low rates of heart disease, cancer, neurodegeneration, and overall mortality. We look at the Okinawans in Japan or the Nicoyans in Costa Rica. They eat tons of lectins, phytates, and oxalates daily. Yet they have some of the lowest rates of chronic disease in the world. Studies on Greek, Italian, and Spanish populations consuming nightshades, legumes, and oxalate-rich vegetables show reduced inflammation, improved metabolic health, and much longer health spans. If anti-nutrients were truly harmful, we would expect these populations to have worse health outcomes. Yet they don't. In fact, the opposite is true. So what's the catch here? It all comes down to how these foods are prepared. Let's zoom in a little closer at the top 5 nutrients I found to be the most relevant. And more importantly, I want to share exactly how to neutralize them in practical ways. Let's start with phytates, also called phytic acid. These are found in foods like soy, whole grains, legumes, nuts, and seeds. The issue with phytates is that they bind to essential minerals like iron, zinc, calcium, and magnesium, making them less available for absorption. And this is exactly why some people claim that eating too many grains, beans, or nuts can lead to mineral deficiencies. But here's the reality. Phytates don't actually steal minerals from your body. They just reduce how much you absorb from the meal you're currently eating. And more importantly, phytic acid isn't just an anti-nutrient. It actually has some pretty incredible health benefits, like acting as an antioxidant and supporting gut health. That being said, if you're relying heavily on high phytate foods for your minerals, it makes sense to pay attention to how you prepare them. Method number 1 is soaking. Soaking works by activating phytase, the enzyme that breaks down phytic acid. This works great for legumes like beans, chickpeas, and lentils, but not so much for nuts and seeds, since they don't contain enough of it to kickstart this process. For grains, soaking does help, but also not fully, since most grains are naturally lower in phytase. Sprouting, however, is an amazing way to reduce phytates in grains. When you let grains sprout, they actually start using their own phytates for energy, and as they germinate, they significantly reduce its content. You can do this at home or look for pre-sprouted grains online or at your local health store. For nuts and seeds, sprouting works a little, but not for all. Again, this will depend on the individual phytase availability, so the next strategy will be the most effective. Pairing with vitamin C. This one's really cool because vitamin C actually counteracts the mineral blocking effects of phytic acid. Studies show that for iron, for example, adding vitamin C to a meal can increase its absorption by up to 6 times, even when phytates are present. Consuming vitamin C in the same meal also helps with zinc and magnesium absorption. So if you're eating nuts, nuts, grains, beans, pairing them with things like lemon, bell peppers, berries, or citrus can help offset the mineral loss. But fermentation is by far the most powerful way to break down phytic acid. Traditional sourdough fermentation destroys almost all phytates in grains. This is why real sourdough bread is far easier to digest than regular whole wheat bread. Same thing with fermented soy products like miso, tempeh, or natto. Fermentation breaks down phytates way more effectively than soaking or cooking alone does. So according to scientific evidence, unless you're heavily reliant on these foods for your nutrition, say if you follow a vegan or vegetarian diet with not much variety, phytic acid is not a real concern, especially if you're using these preparation methods. Alright, let's talk about lectins. You've most likely heard of them, as they are probably the most controversial anti-nutrients out there. Lectins are actually proteins found in beans, whole grains, and nightshades like tomatoes, potatoes, eggplants, and peppers. They bind to cell membranes in the gut, and in high amounts they could cause digestive irritation, interfere with nutrient absorption, and even increase gut permeability. And this is why some people in the carnivore or keto community believe that lectins are toxic and should be avoided entirely. But here's the thing. Almost all lectins are destroyed when food is properly cooked. The real danger comes from raw or undercooked foods that are high in lectins, which in most cases you'd never be eating raw in the first place. So, how do you make sure you neutralize them for good? Boiling will be the best way to eliminate lectins in beans, chickpeas, and lentils. A rolling boil for at least 10 minutes destroys nearly all of them. Pressure cooking is even better. It should remove lectins completely and makes legumes way easier to digest. But the key is making sure they are fully cooked, because undercooked beans still have active lectins and can cause major digestive issues. So never eat raw or undercooked beans, and try to avoid legume flours like soy or chickpea flour that hasn't been pre-boiled or heat-treated. Fermentation is the best approach for grains, because grain lectins are more resistant to heat, so boiling or baking won't get rid of them so easily. Same thing with fermented soy foods. Fermentation makes lectin-rich foods more gut-friendly. For nightshades, most lectins are actually concentrated in the skins and seeds, so peeling tomatoes, potatoes, peppers, eggplants removes a huge portion of their lectins, and high heat, high moisture cooking reduces them even more. That said, some people will be way more sensitive to any amount of lectins. If you have gut issues or an autoimmune condition, consuming lectins might actually aggravate your symptoms. That's why in many studies we see that removing these foods from the patient's diet actually helped improve their condition. But for the average person, as long as you're cooking your food properly, lectins should not be a problem. Moving on to oxalates. Oxalates are found in spinach, almond, kale, beets, and sweet potatoes, as well as in things like tea and dark chocolate. And what they do is pretty similar to phytates. They bind to minerals like calcium, magnesium, and iron, making them less bioavailable. Now, if you're someone prone to kidney stones, oxalates are something you do need to pay attention to, because they can form calcium oxalate crystals, which are the most common type of kidney stone. They can also build up in soft tissues like joints, which some believe may contribute to inflammation and stiffness. But should high oxalate foods be completely avoided? Not necessarily. Once again, it just depends on how you prepare them. So oxalates are heat stable, meaning cooking alone won't destroy them. But they are water soluble, so boiling is one of the few ways to actually reduce their content. But the problem is that a lot of the good nutrients are also water soluble. So if you boil something like spinach, yeah, you're getting rid of oxalates, but you're also leaching out vitamins into the water. And if you're making soup, those oxalates just end up in your broth. So unless you're draining the water, boiling is kind of a trade-off. So this next strategy will be a much better alternative, pairing these foods with calcium. This is honestly the better solution, because when oxalates bind to calcium before they get absorbed, they can pass harmlessly through your body instead of building up and causing issues. And this is exactly why cultures that eat a lot of high oxalate vegetables often pair them with foods like cheese, yogurt, milk, and other calcium-rich foods. So instead of boiling your spinach and tossing the water, just eat it with some feta or a little yogurt-based dressing. That way, you keep the nutrients and prevent oxalates from causing problems in the first place. And as a general rule, avoid too many green juices containing raw kale or spinach. Moving on to goitrogens. Goitrogens are compounds found in soy, kale, broccoli, Brussels sprouts, bok choy, cabbage, and other cruciferous vegetables. And the concern with goitrogens is that they can interfere with the iodine uptake. which could potentially slow down thyroid function over time. But here's the thing. Epidemiological studies have shown that unless you're already iodine deficient and eating massive amounts of raw cruciferous vegetables, goitrogens aren't something you need to stress about. Boiling is hands down the best way to reduce goitrogens in cruciferous vegetables. But again, just like with oxalates, boiling means you're also losing some of the good stuff. That's why steaming is a far better option. It reduces goitrogens while still keeping more of the nutrients intact. If we're talking soy though, fermentation is key. Fermenting soy products into tempeh, miso, natto, and soy sauce will result in way fewer goitrogens than regular soy, which is why traditionally soy has almost always been eaten in fermented form. And here's the easiest solution. Just make sure you're getting enough iodine. Seafood, seaweed, dairy, eggs, and iodized salt all provide iodine, and as long as you have enough in your diet, goitrogens shouldn't cause any issues. And last on the list are saponins. Saponins are found in grains like quinoa, in legumes, soy, and nightshades, and they're known for their soap-like properties. In large amounts, they can irritate the gut lining and interfere with nutrient absorption. Some people with gut issues, IBS, or autoimmune conditions find that they don't tolerate them well. But as always, preparation is key. For quinoa, just rinse it really well before cooking. Most of the saponins are on the outer layer, so this simple steps removes almost all of them. Boiling also significantly reduces saponins in beans and legumes, as long as you discard the cooking water. And just like with other anti-nutrients, fermentation breaks down saponins better than cooking alone does. For soy products, for example, fermented options have way fewer saponins than things like soy milk or tofu. For nightshades, most of the saponins, again, are in the skin, so peeling your tomatoes, potatoes, eggplants, and peppers can help if you're sensitive. So if we look at all of this, anti-nutrients are really not something to be afraid of. Most studies demonizing lectins, phytic acid, and other anti-nutrients are done in lab settings and test tubes, and not real-world human diets, where these compounds are isolated and exposed to rodents or cells in unnatural concentrations. But humans don't eat isolated compounds. We eat whole foods where fiber, polyphenols, and other nutrients all interact within our bodies in complex ways that lab studies just cannot replicate. If anti-nutrients were actually dangerous at dietary levels, we'd see plant-heavy populations suffering from chronic disease. But the opposite is true. Plant-heavy diets like the Mediterranean diet or the Blue Zones diets are some of the healthiest diets there are, with multiple studies pointing to their prolonged health span and longevity effects. So far, no large-scale studies have ever linked plant-heavy diets to long-term harm in healthy individuals. And long-term human studies consistently show that diets rich in plant foods promote health, not disease. So if you eat a well-balanced diet with plenty of minerals, anti-nutrients are unlikely to harm you. The real issue comes when you're already mineral deficient, if you rely too much on unprepared legumes or grains, or if you eat extreme amounts of any one anti-nutrient. But the solution is very simple. Diversify your diet. Prepare foods traditionally and pair foods strategically, like eating oxalate with calcium and legumes with vitamin C. That's it. If you're eating a diverse, whole food diet, there is no reason to demonize plant foods because of their natural defenses. The real takeaway here isn't that anti-nutrients are a problem. Is that context matters, preparation matters, and balance matters. Thanks so much for watching. I'll leave all relevant research in the description as always if you want to take a deeper dive, and I will see you in my next one.